Hello everyone, welcome to this video. So far I have explained how to analyze simple structure such as 2D charts in SAP 2000 already. For now I will explain you to the more advanced uh, exercise of using SAP 2000. So as I mentioned in previous video, we just analyze, we don't care about the section and material and so on. But this video, I will show you how to use the real material, real section, and based on our design. So uh, to do that, let's get into step 1000. So to design a structure in SAP 2000, it is very important to know the basic step before we do the analysis. So the important thing that we need to consider in design, analyze and design is define the material and the load. So okay, now let's go to define the material first. To define the material, just go to define tab in the menu bar here, and then define material. So you can see here, SAP 2000 have two default material. One is concrete and one is steel. So we can click modify here, and we can check the strength of this. Okay, and this one can check the property, the steel grade, and so on. So, but what if we don't want this kind of material? We want to define another material, or we want to modify this. So we can create based on our own specification. So let's do it. Before we go, I would like to change the unit, set the unit properly first. This is the menu that we set the unit. So, but anyway, you can use any unit, and when you convert, they will automatically convert to a different unit. So, okay, let's say I use kilonewton per minute. Now, let's go to material, define material, and I want to add another material. So we can add a material, and we can choose the region and the material. For example, for now, I want to define, uh, let's say, co-form. So co-form, and this kind of material, they gonna have the default standard already. However, we can modify it, or we can uh, create our own grades. So okay, let's click OK, and we can rename it. Can click on modify and rename the material. Maybe this one I just call it core form, and we can modify the material. But I think for steel, it is very obvious for the property. So uh, just click OK. So you can see here the core form material and the steel. They have very similar strengths. This one is yielding strength at 35,000. Oh, sorry, uh, you can say it, 35 megapascal. So uh, how about the core form? Core form, we can modify it, and it almost have the same property. Okay, so it depends on which grade we design for. So next, we can add new material, and let's say rebar. We want to design reinforced concrete. We can click rebar and click OK. So now rebar come here. We can modify it. Wait, not rebar, this one. This one. Modify it. Okay, we can change the grade. We can use, for example, I use SD 40, and we can change the property. Let's say I will use the KC unit. Okay, and then change this to be 4,000 and for 5,700. So this one, you can keep it default. You can keep it like this, or if you want, you can plus 10% to it. 10% of this one to this, and 10% to this. However, I think this one we may not use. It's just for some research, or I think it's out of the analysis and design scope for now. Okay, so just use only these two and click OK. Okay, that's it. Uh, if you want another material, for example, if you want to define the wood structure, we can add new material. And you can see here, there is no wood here, only aluminum, tendon, and so on. So we can add other material here, and then click OK. Now we can name it wood, and we can change the property. We can set the property like this. Click OK. Okay, now modify. Okay, we can modify based on the property, based on the unit weight of the wood. So we can use the grade table or the standard of each material and modify it here. Okay, so now we get the material for concrete, steel rebar, cold form, and steel. Let's say I change this to be steel. This steel is the structural steel, and SD here is a rebar, or it called construction steel, and this one concrete. Okay, so now I will click OK. Now we get the material ready. Next, we need to define the section. So we will define the section based on the material that we just defined. So just go define again, and section properties. So section gonna be frame and slab. So frame will be beam and column and bracing or whatever. So now they're gonna be one default material here. We can either import the new material from a file. For example, I click import, and I want to import the white blank section or tube section. Okay, let's say white blank section, and it's gonna show the file or material that we have in our device. So okay, let's say I use this one, AC, and it's gonna have a range of material here. We can select. We don't have to select all of them, maybe just some, and select. Okay, we can create. Okay, we're gonna have the standard of material here. Now click OK. Okay, now go back again to define and section property. You can see now we have the material. And what if we don't want this material? We can uh, import another one, another section, or we can add a property here. If we add a property here, we can modify them based on our preference. For example, I want to define the concrete. Okay, and I'll name this to be C1. Okay, um, the depth will be 0.4, and this one is 0.2. Okay, 0.2 meter, and change the material to be concrete. Okay, now we're gonna have the concrete section of this C1. Okay, we can modify it, or I want to add the beam. So just add a copy of property. Now the beam, this B1. Okay, we can set section property too. We can see the section property of this. Okay, we can check the reinforcement for the beam. We can use the check into the beam and define the cover, the bar. Okay, for now, we're gonna sort of choose the reinforcement steel here. Okay, so I'll just lay it like this first. This one I think should, let's modify this to be square column and set the reinforcement to be column. Okay, so we can use the reinforcement here for some assume section. We either use to be checked or to be decided. So if we use to be checked, so it will just check the strengths. But if we use to decide, the column will check the capacity ratio too. Okay, click OK. And OK. Next. Okay, now we already have the steel section and the concrete section. We can add another one. Let's say I want to add a steel tube. Okay, just add a tube like this. And we can use the steel table to modify the standard, modify the section here. So let's say, let's go to the steel section. Let's say I use 50 times 25 and 2.3 millimeter thickness. Okay, so we can use the table. You can name it to be 50 times 25 times 2.3, and then you may change the unit to make it easier to understand. So this one is gonna be 0.05, 0.025, 0.0023, 0.00223. Okay, for example, and then we may add another one. This one, we may add a bigger one. This one I may use 75 times 30 times 3 times 3 millimeter. And then this one's 75. Okay, now we already have the section 2. So I think that's enough. Uh, okay, next we need to define the slab. Or if you want to use the slab for concrete structure or steel deck, we can go to section define and then use area sections. Yeah, we can click add new section here, and we name it C slab. C slab. So there are wide range of type of slab here. They gonna be each type of this gonna be used differently. So if we use the slab to if you want to design the slab in SAP 2000, you may use shell thin or plate thin. or Celtic. But if you just want to analyze the slab based on the cell weight and or to apply the load on the slab, you may use membrane. So membrane is a slab that does not take any stiffness from the beam. So if you just want to consider about the weight, I think I suggest you to use membrane. But if you design the slab, you may use Shelton, Celtic, or other membrane based on the definition. So okay, now as C slab, let's say I want to uh, just want to apply the load. So I'm gonna choose membrane and thickness thickness maybe just 15. Okay, the material is gonna be concrete. Okay, that's it. Click OK. And how about the roof? We can add the roof in SAP2000. I think there is no material for the roof metal sheet. So we can define some section that we can assume to be roof. So I'm gonna use membrane again, and I name this to be sheet, and the thickness may be very small. Gonna be hmm, let me change the unit first. A bit confusing for me. I will change to kilonewton centimeter. Now go to area section, and I want to we can modify this. Change to RC slab and use membrane. Now the thickness gonna be uh, 15 centimeter, 15 centimeter, and choose concrete. Now click OK and add new section. So this one I'm gonna say it's a steel sheet. So I'm gonna use membrane again, and the thickness maybe just 1 millimeter, 1 centimeter. Okay, we can assume the thickness. Or other way, on the other way, we can uh, ignore the cell weight of it. So this method is just I think depend on the user. So I will not consider about the metal sheet because I'm not sure about the weight exactly. So I'll just go to set the modifier here and set the cell weight to be 0. But when we decide if we set the cell weight to be 0, we should apply the cell weight as a dead load later. So please be careful when if we ignore some load, it might affect the structure. So you can calculate manually and apply as dead load, or you may try this way. Uh, use the full weight cell weight of the section that we define. Okay, now change this to be steel. Okay, now everything is okay now. Okay, I think I have different type of slab already. So I have the sheet and the uh, RC slab already. Now click OK. Sometimes we may need to use the wall too, the shear wall. So we can define. I think it's the same. Okay, I think it's the same. Yeah. So we can just add another shear wall, or or mm, masonry wall is okay. Just say wall, and I'm gonna use membrane again. I will not design the wall, so the wall maybe 12 centimeter, 12 centimeter, and gonna be concrete. Okay, I think that's it. Okay. Okay. Now we already defined the section. We can start drawing on the model. Uh, okay, but before we draw the model, I want to let's go to define the load first. So to define the load, we can go to define, and we first of all define load pattern. So load pattern here, you're gonna have the dead load automatically here. Now if define live load and change the type to be live. Factor 0 cell weight. Live load is no cell weight, so just add. And win load, win, and we change this to be win. For win load, there are two types, so we can either choose the standard here, and it's gonna be auto lateral load. So the program will automatically calculate the load that affect the building for us. But if you want to uh, apply the load by yourself, you still define like this, but just change this to be norm like this, add load pattern. Okay, so I will define both type. So I'll define one is not automatic, this one is not automatic. We need to apply manually, and this one is the program determined for us. So I will choose the standard here. Let's say I use a ASC 6 2016 and add or name it to be WinO, Win Auto Load. And next, define earthquake load. So let's name it quake and change this to be quake. Quake means seismic load. So again, earthquake load is similar to wind load. You can choose the standard known or uh, use the standard. Okay, let's say for earthquake, I will use the program to analyze. So I just choose the standard here. It will automatically consider the uh, parameter. So let's say I use the international building code and add. Okay, now we have the load already. You can define other load if it related to your project. Okay, now click OK. Next step, we need to define the load combination. So in SAP2000, you the program will automatically calculate the load, each load type. You can analyze them separately or analyze them like a load combination. So it is very convenient. So just go to add load combination. Now add load. And actually we can use the default load combination here. For example, uh, we need to choose the standard. So before the program, we choose the standard already. So it will automatic add the load based on the standard that we choose. Uh, for example, if we choose the steel structure, we uh, click OK. Now it will have wide range of load combination, and that based on our load that we define. For example, if you click on it and modify it, you can see here it's gonna have the dead load and live load for the case two. For example, other case, let's check other case. So it's gonna have the win load, the live load, dead load, and so on. There are a lot of load combination based on the standard, but I think these are too complex. So I will just define my own. So let's say I define my own. This one combo one, add dead load and live load. Oh, okay, this allowable. combination, and then add another combo for dead load one factor 1.2, live load factor 1.7. Okay, and another one, uh, dead load 1.2, live load 1, uh, win load win. We need to choose either one of these. So if you use the manual method apply by yourself, you should not use the other one. So if you use the auto load, you should not use the manual method. So it's up to you. So let's say I just use the auto one. I'm gonna use this to be 2.6. Okay. And next, for earthquake, we can define the same. Dead load 1.2, live load. This one you need to check the standard or the building code that you design. Quick. Okay, now we have all the load combination already. Next, okay, now click OK. Now just draw the model. Draw the model by clicking the draw tool here, or you can go to draw and select the tool that you want to draw. Let's say I want to use the quick tool draw for frame. Okay. Okay, for quick tool draw, we just select the section. Uh, this page will come out and select the section. Let's say I use concrete first, concrete column. Okay, now they will automatically draw. So we can modify it. Let's say, okay, this part I will use the roof. So I'll delete this first. And I will let's go to ZY plane. Okay, now I will draw this. You can do right click to stop the drawing. Right click. Okay, now it's complete. However, you can see that I use the C1 for all. C1 for all. We can right click in the member and go to check the location, the distance, and assignment. So you can see here the property section is C1. So we can right click on it to change, or on the other way, we can select all the frame. Okay, we can select all the frame, the roof, and go to this side, assign, and frame section property. For this one, I'm gonna use steel section. So let's click apply. Okay, and we can use the select. Um, Let me select. Okay. I just want to change the beam to here to beam B1. So we just select all the beam and also the roof. So if you right left click in the mouse, press and you drag it from right to left, every object that touch the mouse will be selected. But if you drag from left to right, only the fully object that cover in the area will be selected. Okay, now this all of this and all of this. Okay, I will change to B1. Assign frame section and B1. Apply. Okay, now we can check. Go to set display option and frame section, or we can view the whole project by the section color. Now click OK. Okay, here is the section color. You may do extrusion, just set display and general. Use view type by extrusion. Okay, this is how it look. Next, we haven't draw the wall. Let's draw the wall. Go to XY, XZ, and draw wall. Now I will draw this one. You can choose either square or polygon or quick draw. I will choose the wall. Okay, this one is a RC wall, but I just show as an example. You may use different wall. You can also use the imaginary wall. Okay, I use the quick tool. You can change to the wall that doesn't have the property and no, that means no cell weight, but they gonna have the area. So let's say I use my wall and just select the area. Or no, they're gonna, okay, I can delete it later and move to another plane. Okay, I think it's not correct. Should be this one. Okay, next, to draw the roof, uh, we can use the extrusion. Okay, let's draw the roof. Just click extrusion to the frame here and just click select two frame and go edit extrude from line to area. Hmm? It's a bit slow. Let me check the distance. So the area is 6 meters. Okay, again. Uh, edit extrude line to area. Okay, I make a mistake. Let's select again. Go extrusion line to area extrusion. Okay, now it's come out, and uh, we choose the property to be sheet, and we're gonna extrude in the x direction. So y gonna be 0, but x, the spacing of this is gonna be 6 meters, and the member I use three interval. So let's click apply. Okay, here in the roof come out. Okay, okay, now we good. Ready? Next step is to apply the load. So for the dead load and live load, we can apply directly. Oh, I haven't cleared the slab. Okay, let's clear the slab first. Go XY plane, and draw slab. And we're gonna use the RC slab. Just quick draw two and one, and this one. There should not be slab here. Okay, so this is the slab for the floor. Next, to apply the load, so we can apply as a area load. So just select all the area and go to, let's change the unit first. Change to be uh, whatever unit. I think I will use kilogram per meter. Okay, kilogram meter, and go to assign and choose area load and uniformly distributed or just gravity. Okay, this one is just gravity. Uh, Gravity it will transfer automatically as a dead load or as a load to the floor. So we can choose live load or dead load. Okay, this one I'm gonna use the dead load first. So in the Z direction, I will use 120. Now apply. Let's close extrusion. Okay, you will see the load apply on the floor. And next, change to live load, and we choose the previous selection to select the floor. Now apply the live load. Okay, now the live load apply to the floor already. I think the grid. I don't like the grid now. Let's go view and turn off the grid. Okay. Next, select the roof and apply the live load as 50. Okay, now everything is okay. Now let's for the wind load and earthquake load. For earthquake load, it will automatically use our building based on the code that we define. It's called the automatic load, so it will automatically affect the building. Uh, However, for wind load, we need to define the type of wind load. So let's go define again. Uh, Load pattern. So, oh, why? I think I said so many load here. Okay, let's go to define load pattern, and we should use there are two function here. One is a rigid diaphragm. This one is gonna be like we analyze high-rise building, and the slab gonna act like a diaphragm. So I think we will not use this one for now. We will use only the area because it's just the wall from outside. So we will use the area pressure, and then we can put the stand coefficient. This one, if it's an open structure, we click the other one too. But if just a closed structure, we will use object area. Okay, now click OK. And next, we can apply the wind load. Okay, we can you choose which side is the wind load and which side is the leeward. Okay, let's say I use this first. Before we apply that, I want you to click go set display option and select area use local axis because because the wind load will uh, affect perpendicular to the floor that we apply. So sometimes when we draw the floor, it might be switch the local coordinate will switch from the other to the other side. So just click like this to check the local coordinate, and now go assign uh, area load, but now use a wind pressure coefficient. Okay, now choose this to be wind and windward or leeward. The coefficient gonna be 0.8. Load distributed. Think this one. Okay, we can use. Uh, I think it should be two way or one way. One way. Okay, and then click apply. Make sure it's a. Oh, this one is a lever. Sorry, I'll use this lever. Now let's apply. Okay. Okay, now our wind load is applied to the wall already. Next, choose this side and apply as a wind load. Now apply. Okay, you can see here the axis. Now it point toward inside, and the wind is from right to left. That means it's correct. But sometimes the coordinate here gonna turn like left to right here. So you might need to use the negative side here. But now it's okay for my model. The next for the roof, also windward this side. Apply. Okay. Now leeward. Okay, you can see here now the axis is going downward. So uh, for the leeward, it should the wind pressure should point perpendicular to the surface to the other side. So this one we need to use the negative 0.5 and level. Okay, now everything okay. So next we can run the analysis. Okay, I think this include this tutorial. I show you how to define the load, the section, the load, and apply the load already. Next step is gonna be the analysis and design. So see you next video.